Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that solve the homogeneous differential equation x squared minus y squared dx is equal to minus 2xy dy. So a homogeneous equation is any equation of the form p plus q dy over dx is equal to 0. Any equation of this form is called a homogeneous equation, whereby p and q are homogeneous functions. So we are going to express this in this form because this is a homogeneous equation, but it's expressed in another form. So we will bring this to this side. X squared minus y squared dx plus 2xy dy is equal to 0. Then to get dy over dx, we will divide 2 by dx. So if we divide here by dx, we'll get x squared minus y squared plus 2xy dy over dx. 0 over dx is 0. So now we can put this in bracket. So now this equation now resembles this equation. So this one will be our equation 1. Then this one will be our equation 2. So 1 and 2 are identical. So now let's proceed. Now from equation 1 and 2, we have that you compare equation 1 and 2. You will see that p is equal to this function and q is equal to this function. And dy over dx is equal to dy over dx. So now we can see that p is equal to x squared minus y squared. Then q is equal to 2xy. So now, since this is a homogeneous equation, we are going to make a substitution. We are going to make a special substitution. Now we will let y equals to vx. This is the substitution we are going to make into this homogeneous equation. So we solve homogeneous equations by making this substitution. Y is equal to vx. Then this will be our equation 3. Then we will differentiate this equation. It will be dy over dx is equals to, then you differentiate x. If you differentiate x first, you get what? You get v plus, because we are using product rule here. Then if you differentiate what? If you differentiate v, then the derivative of v with respect to x. So we know that derivative of x is 1, but that of v, we will still express it like this. We will not put any value for the derivative. We will just put the v over the x to signify the derivative of v with respect to x. And that will be our equation 4. So now we're going to substitute equation 3 and 4 into 2. So we'll say substitute equation 3 and 4 into equation 2. So this 3 and 4 will substitute back in the 2, in the original equation. So it will be what? Wherever we see y, we will substitute it for vx. And whenever we see dy over dx, we substitute it for this. So here's the equation. So x squared to be x squared minus what? Minus vx. It will be vx square. So but let me open it. It will be v square x square. Since it's vx all squared. Then plus 2xy. That means it will be 2 times x times vx. So it will be 2vx square. 2vx square. Since y is vx, so it's vx square, 2vx square. Then dy over the x be this p plus x dv over the x, which is equal to 0. So now we are going to simplify this equation. What we are going to do is we are going to divide all two by this, the one before this, so that here will be left only with the expression in this bracket. So we're going to divide all two by this, so which is 2vx square. So if we divide x square by 2vx square, we will get 1 over 2v. So here becomes 1 over 2v minus v square x square divided by 2vx square is what? Then v square x square over 2v x square is what? X square and x square will cancel. So it will remain v and 1v here will cancel the other v. So it will be v over 2. So it will be v over 2 plus v plus x, the v over the x is equals to 0. So now we'll collect like terms. So here will be x so this will go, become v over 2 minus 1 over 2v minus v. So the LCM of this is 2v. So 2v times v is what? 2v squared divided by 2 is what? V square. So this one, 2v times 1 is 2v divided by 2v is minus 1. 2v times v is what? Is minus 2v squared. So x, the v over the x. So now now v square minus 2v square is what? Is v square. So now v square minus 2v square is negative v square. So here becomes x, the v over the x is equal to negative v square minus 1 over 2v. So now we will take the inverse of both sides. So now here if we take the inverse, it becomes the x over x the v. So now will be this one, so here will be 2v over negative v square minus 1. So now we will take this dv here. So it will become the x over x is equal to 2v. We can factor out minus here from the denominator. So it becomes minus v square plus 1. Then the v. So now we can bring this term back to the left hand side. It becomes the x over x. Since there is a minus here, if you bring it here, it becomes plus. So it's plus 2v over v square plus 1. The v is equals to 0. So now all the terms of x are on its own. All the terms of v are on its own. So we can find the integral. Here we'll find the integral. Here we'll find the integral. And also this we'll find the integral. So the integral of this becomes, this is 1 over x times the x. So the integral of 1 over x is what? It's ln x. So here becomes ln x you can put 2 bars like this. So here is ln x plus, then here you factor out 2, then to be v over v squared plus 1. To find the integral of v over v squared plus 1, we will have to use substitution method. So let's do it at this side. We will say t will be equal to v squared plus 1. Then the t is equal to 2v. Then this is the t over dv. That is the derivative of t with respect to v. So there will be dv divided by dv. So I'll put it here. Then, since v the v is common, we are going to make v the v the subject of the formula. So v the v will be what? The t over 2. So now, we will put this in this equation. It will be what? Integral of what? V squared plus 1 we have equated to t, so it will be 1 over t times this, the t over 2. So now, we are going to bring out this 2 when it comes out here to cancel this 2. So it will be 1. Then to remain the integral of 1 over t, the t. The integral of 1 over t is what? Is ln t. So, and what is t? T is v squared plus 1. So this is the integral of this term. In some of my previous videos on integration by substitution method, I did many examples on substitution. If you want to understand how I did this better, you can check out those videos. The link of the video is in the description below. So it will be what? Ln v squared plus 1. Then the integral of 0 is what? It's a constant. The integral of 0 is a constant. Many people usually confuse the integral of 0. Because you know that the derivative of a constant is 0. So now, if I want to find the integral of 0, it will mean that I am finding the integral of the derivative of a constant. So now, this integral will cancel this derivative. The answer now will be 0, will be a constant. This integral, this integral and this d dx, d over dx will cancel. So what will remain now is c. That means the integral of 0 is constant, not 0. C, which is equal to a constant. So the derivative of a constant is 0, and the integral of 0, which is the derivative of a constant, is a constant. So this now will be equal to c, which is a constant, because the integral of 0 is the integral of this, and it will cancel d dx. So now you know that there's an equation in terms of v here. So we want everything to be in terms of x and y. So now we'll substitute equation 3. So we'll substitute equation 3. So now we'll substitute this equation 3 into that equation, which says that y is equal to vx. So this will be our equation 5. The last one is 4, so this will be our equation 5. And we will substitute this equation 3 into it. So now from here, from here you can know that v is equal to y over x. So anywhere we see v, we'll put y over x. So now here will be y over x. So here will be ring x plus ring y over x square is y square over x square plus 1. So these are absolute brackets, meaning the ring of the absolute value of this. This bar I'm drawing is a bracket that shows absolute value, meaning that this is the natural logarithm. This means that the natural logarithm of the absolute value of x, and this is also the natural logarithm of the absolute value of y square over x square plus 1. So these two bars, they are not like a normal bracket. They are absolute brackets. So you can actually leave the answer like this, or you can further simplify it. So you don't want to further simplify this answer. Since this one is a natural logarithm and this one is also a natural logarithm, we are going to, and it's plus, according to the laws of logarithm, we are going to take this ring of, since it's plus, is times. So they'll be times in each other. X, open bracket, what? Y square over x square plus 1. So is equal to c. And then to remove this natural logarithm ln ring, we'll take the exponent of both sides. So the exponent of this side, when we take the exponent of this side, this ring will cancel. So it will be exponent of ring x y square over x square plus 1 is equal to exponent of c. So now this exponent and this ring will cancel, so it will become this term. So now we can even open the bracket before we write it down. So it will be x times y square over x square is what? Is y square over x. So it will become y square over x plus x times 1 is equal to exponent of c. So now we are going to say we are going to equate exponential c to a. So we are going to say let a equals to exponential c, or we can take any variable we want. So now it will become y square over x plus x equals to a. Then we will multiply 2 by x, so this x will cancel. So it will become y square plus x square is equals to ax. So now we can make y square the subject of the formula. So it will be y square is equals to ax minus x square, where a is exponential c. So this is the final answer. This is square. So let me write again. So y squared is equals to ax minus x squared. A is equals to exponential c. So this is the final answer. We have successfully solved the homogeneous differential equation. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.